Suppose I had this image of a Ferrari and I want to insert this image onto it, as if it were a decal applied by a car wrap service. How would it look if I tried to do it by hand? Now, I'm no professional at Photoshop, but even if I were, this isn't something that can be done well in just a few clicks. There's two reasons as to why producing a natural-looking insertion is such a difficult task. The first is that insertion has to consider the three-dimensional geometry within the image. If it just gets inserted without really considering the sculpture of the surface it's being applied on, it's going to look, quite literally, out of place. So, any good insertion method must have some level of geometry awareness.
Second is that if photorealism is the goal, you should always respect the lighting of the scene. If a scene contains shadows or reflections, then they should also appear on the logo. Failing to do so is bound to create illumination discrepancies that will indicate that the image has been edited. Moji, developed by Wang et al., does a pretty good job of estimating a point cloud from a two-dimensional image. This enables us to perform geometry-aware editing on the image. Intrinsic decomposition, in broad terms, is the process of separating object material properties, known as albedo, from scene lighting, known as shading. Research by Careaga and Aksoy has proposed a data-driven method to perform this decomposition.
Here's the pipeline of our proposed method. You can imagine we are simply applying a decal onto an object surface and retaking the photo under the original lighting conditions. Let's go through a demonstration using the tools we've developed.
We begin with geometry estimation. Our code will call Moji to get a 3D point cloud and then convert it into a 3D mesh.
With the mesh loaded in Blender, press F8 to select the source image. With the image loaded, we can then direct where on the mesh it will go. This is free to control by the user, so you can place this anywhere you'd like. Use the scroll wheel to expand or shrink the region the image will be applied onto, then press Enter to apply the source image. Odds are the texture mapping is not going to be what you want, so our panel on the top right includes controls to tune the mapping. For the sake of keeping the video short, we'll be fast forwarding through this step. Now that's looking good. The final step is to include a resolution of the target image and the camera FOV estimated by Moji. The file will be saved in the same directory as your Blender scene, so be sure to save before you render.
For logo rendered, we can now insert it. Our code will call the intrinsic decomposition to get the albedo and shading of the scene. The logo is inserted into the albedo layer, and then the shading is re-added, creating our final image.
Here's a few more examples demonstrating our results. Now, our method isn't perfect. There are some limitations that prevent it from being a one-size-fits-all solution.
First of all, the tools that are the basis of our geometry scene awareness don't always get it right. For example, Moji can have trouble estimating geometry if you give it an image that does not have a lot of background detail. Take this picture of the Canadian flag. It's rippled quite dramatically, so you'd expect there to be a big difference in depth around the flag. However, the background being a clear sky means that Moji doesn't have a lot of information available to estimate the depth. The resulting geometry ends up being quite flat, so any inserted logo will also look flat, giving a not so accurate result.
The second is that the tools for intrinsic decomposition can sometimes struggle with figuring out whether detail belongs to object material or lighting. If we look at the individual layers of the flag here, we can see much of the flag's pattern has ended up on the shading layer, which is not correct. This ends up with pattern detail being written on top of our inserted logo, giving us this oddly composited result. That being said, we found our method gives great results across a wide range of contexts. Give it a try and see what kind of cool insertions you can come up with. Stop by our GitHub page for more information on installation and use. Thanks for watching.